Good morning, everyone. I hope I am audible to all of you. Deepak, Ritik, Farin, Shireen, Pooja, Atharva, Mansi, Suprapti, Sandhya, Rituja, Shwetanjali, Praveen, Akash, Hemangi, Utkarsha, Vaishali, Namrata, Jagruti, Annan, Pranjali, Nisha, Prajoti, Leena, Pooja, प्राजक्ता, नूजा, ओजल, राधिका, मानसी, साजिद पठान, इतना बड़ा गुड मॉर्निंग, विशाखा, निकिता, नीतीश, गुड मॉर्निंग. ओके, एम आई ऑडिबल? हेलो, यस, आई थिंक आई एम ऑडिबल. सो लेट्स गेट स्टार्टेड. प्रणाली, प्रणीता, आकाश, प्रांजलि, रमेश, स्नेहल, निशांत, दर्शन, अमर, प्रचिति, सीमा, पूजा, हर्षदा. वेलकम यू ऑल. लीना, सिद्धि, प्रज्योति, नम्रता, ममता, श्वेता. ओके, वेलकम ऑल ऑफ यू अगेन. सो लेट्स गेट स्टार्टेड. As decided, okay, is there any problem with respect to? Don't think so. Okay, so as decided, we will moving towards the next fascinating technique called as thin layer chromatography. Okay, thin layer chromatography. Okay, yes. Pratiksha Kimaya, good morning and welcome. Okay, so what I mean to say, the first line over here is that you just have to remember whatever we have learned in paper chromatography. Okay, to understand, it is a very simple technique, TLC, as compared to even paper chromatography also. Okay, so whenever we were discussing thin layer chromatography or TLC, you just have to remember what we have discussed already in the paper chromatography, because both these techniques are very similar to each other. The only difference is of a stationary phase. Okay, the only difference is, or a major difference is of a stationary phase where it is a thin layer. Okay, a thin layer. What is the thin layer? How this thin layer is prepared and what is its significance? We will have a discussion over it. But the only difference with respect to the paper's stationary phase and TLC stationary phase, it's only TLC combination or stationary phase combination. Okay, Prakshep Kadambari, good morning. So introduce the TLC. The TLC is a form of liquid solid chromatography. It is a form of liquid chromatography, but when we say more specifically, it is a form of liquid solid chromatography. Okay, where liquid is what? Your mobile phase. Where is the mobile phase? Here is the mobile phase, or a developing solvent, we can call it as the solvent which helps for the separation or the movement of the solute is called as a mobile phase or developing solvent. S is what? The solid material or adsorbent material on which the adsorption of the mixture components will take place is what S stands for. That is a stationary phase. A plate, strip, remember, a plate or a strip, maybe a glass strip, maybe a plastic strip, okay, coated with a form of silica gel. Silica gel has been prepared and it has been coated with respect to the plate, so that you can get a uniform layer of silica upon the plate or a strip, to be called it as a stationary phase. Okay, so this is the what? The mobile phase, a stationary phase. And analysis is performed on the flat surface. Flat means what? It's a plate. Okay, this plate looks like our paper, cut paper. We will have a diagram in the next slide itself. Okay, so this plate will have coated on it the silica gel. Okay, the silica gel has been coated over it, and it has been used as what? A stationary phase. It is a flat surface under atmospheric conditions. Okay, remember this, under atmospheric conditions. These atmospheric conditions requires two prominent characteristics. Okay, Dipesh, good morning. Two prominent characteristics. What I mean to say is, when you are going to perform the analysis by using thin layer chromatography, it has to be done, or what we can say, it is appropriately. The advantageous thing with respect to the TLC is that you can perform the analysis by TLC at atmospheric conditions itself. These atmospheric conditions at a time involve the atmospheric pressure, which is itself is present at the laboratory scale. Okay, the pressure which is present at the lab scale can be utilized for TLC development technique. Okay, lab scale to atmospheric temperature pressure. Apart from the pressure, you can utilize the room temperature also. There is no excessive or a critical requirement as such with respect to the atmospheric conditions for the TLC with respect to the pressure or the temperature, and that's why this technique has gained more acceptance in the academic and research field as compared to so-called as a more sophisticated and advanced technique like HPLC and HPTLC, because these instruments, apart from having expensive in the nature, they require a specialized atmospheric conditions also. Okay, while TLC or even your paper chromatography does not require any sort of atmospheric conditions. Okay, so these atmospheric conditions at a time can be controlled in the TLC, and you can carry out the practical very efficiently at the lab atmospheric pressure itself and the lab room temperature itself. Okay, so these are some of the ways by which you can introduce the TLC. As we all know, this scientist Michel Sweets, we have already covered it. He is the father of liquid chromatography during the what you can say earliest century of 1900. He has started his work and started separating the pigments, what you can say plant pigments, one from the another, and from there he gained the idea that we can have this chromatography as a separation technique, and for that purpose he utilizes these so-called as a column and TLC plates methods. But as we already discussed, the two scientists which we have effectively contributed in 1945 and 1950 has advanced the technique with respect to the dimensional variability, the mobile phase composition, the stationary phase composition, and thereafter the chromatography evolution has gained its momentums. Okay, but the father of liquid chromatography will always remain be a Michael Sweet. Okay, Nahid, Chirag, Raj, Yadav, Priyanka, Akshaya, Bhuir, welcome and good morning all of you. So we have already dealt with the normal phase and reverse phase also. So normal phase, as we all know, division between the stationary phase and a mobile phase. Okay, stationary phase and mobile phase division will be dependent upon what you need actually. If you need the stationary phase, which we will polar one, then it is a normal phase. Okay, in the normal phase, stationary phase is polar one and mobile phase is non-polar or less polar in nature. There is a difference between non-polar and less polar. Okay, somewhere in between polar and non-polar. Okay, polar and non-polar, these two extremities of the polarity, in the between these two extremities of the polarity, your very low polarity compound lies. Okay, a very low polarity compound lies. Non-polar means totally against the polarity. Okay, totally against the polarity. It does not show any sort of polarity. And polar is excessively polar or affinity to the water soluble components, while very low polar is somewhere in between these two extremes. Okay, so remember the term very low polarity. Okay, now in case of normal phase chromatography, as we have seen, the stationary phase is polar in nature, but obvious choice remains in case of mobile phase is non-polar, or more specifically organic solvent, because they are very low polarity in nature, or we can classify them as a non-polar in nature. Okay, you can go for the mixture of organic solvent we have already dealt it with, and which is less polar than the stationary phase. Remember, normal phase, polar, stationary phase, and non-polar mobile phase. When we compare it with the reverse phase, we already dealt it with. Reverse phase is a terminology where the stationary phase is silica bound or silica bonded with an organic substrate. Okay, such as a long chain. Remember the long chain aliphatic. Remember the long chain aliphatic acids like C18. Sir has already discussed regarding C18. Okay, now the primary requirement with respect to the reverse phase is that your stationary phase needs to be non-polar in nature. Stationary phase needs to be non-polar in nature. And how you are going to impart the non-polarity into any particular substrate or any particular compound is just by increasing the chain of its carbon compound. We must have read it in the organic chemistry itself. As soon as you go on increasing the carbon numbers, its hydrophilicity decreases and it is going towards more hydrophobic or even more non-polar in nature. And that's why the C18 effectively can be classified under the name of non-polar substationary phase. Okay, and this is effectively been used in case of reverse phase chromatography. The obvious choice remains for the mobile phase is that it should be the mixture of water. Why water? Water is a polar in nature, or any organic solvent to be get dissolved with water so that its polarity gets decreased. Okay, and you will get the more polar mobile phase. Okay, so what is the primary requirement in case of stationary phase? It is that you need to have a non-polar stationary phase. And how you are going to manufacture or even go for non-polar stationary phase, you just have to go for silica bonding. Now what is the silica bonding? Silica bonding of organic substrate. In this case, it may be any long chain aliphatic acids like C18. Carbon 18 aliphatic acid can be chemically, not synonymously, chemically can be treated with the hydroxy group of a silica. To get a removal of this hydrogen to get attached with the carbon 18 aliphatic acid, and hence its polarity gets decreased and it is shifted towards more non-polar in nature. Okay, this is how the reverse phase chromatography stationary phase can be developed. I hope this idea of C18 is clear to you guys now. Neha, good morning. Now what is exactly thin layer chromatography? As I already said, whenever there is a thin layer chromatography, whatever we have covered in the paper chromatography, just remember those simple techniques which can be synonymously or can be compared with the TLC, so that you can get a very good idea regarding what exactly should be the explanation with respect to the TLC. Chromatography, this chromatography technique is used for the separation of mixture of the substances into their components. No need to discuss itself. This is the basis, or what we can say, this is the foremost application of the chromatography is that to separate the mixture of the substance into their individual components. This is what the basis of chromatography, and that's why this also forms the basis of your thin layer chromatography. Now similar to the paper chromatography, except that the thin layer of some inert material, that is aluminum oxide, magnesium oxide, silicon oxide, is used instead of paper. The only difference with respect to the paper chromatography is that it utilizes a thin layer of inert material. Remember the two keywords over here, thin layer and inert material. These two are the keywords while explaining the stationary phase with respect to the TLC. Okay, now when you compare the paper chromatography and thin layer chromatography, principle remains the same, operation remains the same, atmospheric conditions remains the same, practical requirements almost remains the same. The only difference with respect to the paper chromatography and thin layer chromatography is that paper chromatography utilizes this paper, or more specifically Wattmann filter paper, as your stationary phase. But in case of thin layer chromatography, as the word thin layer itself suggests, that you need to have some thin layer on a substance, on a so called as a support, maybe a glass, maybe a plastic, or maybe a aluminum foil. Okay, on that you need to have a thin layer of some inert material. Now what are the choices of inert material? Aluminum oxide, magnesium oxide, silicon oxide, which are majorly used depending upon the composition of the inert material, whether you are going for aluminum oxide, whether going for magnesium oxide, whether you are going for silicon oxide, the polarity of the stationary phase differentiates from one another. Remember this, the polarity of aluminum oxide is different from the magnesium oxide, and which is very different from the silicon oxide. Okay, and depending upon the composition which we use in case of stationary phase formation, its polarity shifted from one another, and depending upon the composition of what you are going to analyze, this choice of any of these inert material will be dependent. It may be aluminum, it may be magnesium, or it may be silicon oxide. Okay, have you got the basic difference between the stationary phase of paper chromatography and a stationary phase of TLC? Okay, the layer of any one of these oxides is made from the slurry. Remember the word slurry, because very important word over slurry is that of powder. That should be D over here, powder in a suitable inert solvent. Remember the another term over here is inert solvent. What you need to do is you have to prepare the slurry of these oxides, any of these oxides, aluminum, magnesium, or silicon oxide, by using inert solvent. Now the slurry is an important component over here, because the consistency of this slurry will have its direct impact on the isolation and separation characteristics of the TLC. Hence this slurry word is very important over here. Now what you have done with respect to the selection of inert material, either you have go with the aluminum oxide, magnesium oxide, silicon oxide. Okay, now the slurry needs to be prepared by using this powder in an inert solvent. That should not be soluble, that should be inert, to produce a slurry. Now this slurry is spread over a flat surface. Now this slurry requires a surface which is a flat one, like a glass, a metal, or a rigid plastic. Okay, metal surface, aluminum foils can also be used for these purposes. Even at the laboratory scale itself, you can use your slides, that slides which you have used in case of microscopy examination can also be used for the formation of your stationary phase in case of TLC. Okay, so these flat surfaces requires, and these flat surfaces to be get encoded with the slurry which you have prepared it with the help of your suitable inert solvent. Okay, suitable inert solvent के साथ में आपने slurry prepare कर लिया, एक appropriate oxide choose कर लिया था, उसका आपने slurry prepare किया और उसको flat surface पे आपने spread कर लिया. Now the spreading needs to be uniform. There should not be any form of so-called as divergence. Okay, this slurry spreading should be uniform one. Okay, this is the primary criteria, and to avoid, because this slurry to be get pour uniformly. Okay, if you want to pour the slurry uniformly on the flat surfaces, it requires a high skill. Okay, it requires a high skill, and that's why there is a demand right now going on with respect to the so-called the commercial TLC plates. Okay, commercial TLC plates utilizes the so-called aluminum foil as a base and silica gel as its major stationary phase composition with a uniform layer spreading of the slurry. And that's why, to avoid so as to get the flat surfaces, okay, uniform surface spreading needs to be there, the commercial TLC plates are right now widely used in case of academic research also, and even in the industrial application also. Okay, these, if suppose you prepare it by using your own slurry preparation, you pour it, then dry it. Okay, then dry it in the oven, and it requires activation. This step is over there in our discussion afterwards. Okay, so what is the principle? No need to discuss as such, because it is a form of liquid solid chromatography. The adsorption is what the basis of principle. Okay, if it is a liquid chromatography, what should be the principle? That is the question. If it is the LSC, liquid solid chromatography, it is adsorption, and if it is a liquid chromatography, what should be the basis? The component with more affinity towards the stationary phase travels slower. Remember this. This is there for the principal purposes. Okay, what I mean to say is, if any compound of a mixture, if any component of a mixture will show the higher amount of adsorptive affinity. What does it means? More affinity means what over here is it shows higher affinity towards the stationary phase. That means it has a major or higher adsorptive capability towards the stationary phase. And if such a compound, if suppose I have three compounds with me, A, B, C. If suppose I have three compound A, B, C with me, out of these, if suppose A compound will have higher affinity towards the stationary phase, that means it shows highest amount of adsorptive capability towards the stationary phase, it retains, it will be retained at the earlier phases of the plate itself. Okay, somewhere here. Okay, somewhere here A is get retained. B is somewhat less shows a lesser affinity towards the stationary phase, and that's why it gets carried away with the mobile phase and it will elute out somewhere here. Okay, this is the B. And if C shows least amount of affinity, it is carried away further. It is carried away further with the help of your mobile phase towards the end of the plate, and it will get eluted out first. Okay, it will get eluted out first because it is least affinity towards the stationary phase. What I mean to say, if any compound will be showing the adsorptive capability towards that compound, it gets retained on the stationary phase as compared to any component of the mixture which has a lesser affinity, or more specifically lesser adsorptive capability towards the stationary phase, that will travel fastest towards the end of the TLC plate and it will elute out first. Okay, so this is what the principle behind your thin layer chromatography. Now what are the advantages? It's just a matter of time, no need to discuss, because you all know the advantages with respect to the paper chromatography. Same can be applicable with respect to the TLC also. It is a simple method, no need to explain, because you need to have only TLC plate. You can carry out the practical at the laboratory setup itself. You can even use these so-called as a jar. or even simple beakers for the saturation purposes also. Okay, it is simple method, cost of the equipment is low, even minimal. Okay, a rapid technique hai, not time consuming like the column chromatography. Column will requires a higher amount of time with respect to the elution characteristics as compared to your TLC. Separation of the microgram quantities, remember, separation of the microgram quantities can be possible with respect to the TLC. Any type of compound, remember, any type of compound can be possibly analyzed depending upon your capability to spot a particular sample on the TLC plate. This compound can be analyzed. Corrosive spray reagents can be used without damaging the plate that needs a laser solvent. Okay, and needs a laser solvent. Okay, if you have any corrosive spray reagents with respect to the spraying agent, as we have discussed it in the case of specific detection technique in the last session itself, if that compound will have, or even that spray reagent will have a corrosive property with respect to the paper, that can be easily sprayed on the TLC plate without causing any damage to the plate. And apart from this, you can use the beaker for the development purpose itself, and beaker itself requires a less amount of solvent. Hence, overall TLC can be utilized for lesser amount of solvent itself. Okay, so these are the certain advantages. Now, what are the steps involved in the TLC analysis? We are going forward. Apparatus, that means a developing chamber. Stationary phase, mobile phase. Application of the sample, that means spotting. More specifically, it is called as a spotting. Development of the plate, we already dealt with the different so-called the development dimensions with respect to the paper. Same can be applicable with respect to the plate also. The last one is after the development of the chromatogram, how you are going to detect the analyte. Okay, so the general procedure is, first you need to decide what is the composition of your sample components. Okay, it is whether a polar or a non-polar. On that basis, what should be the exact composition of the phase chromatography, whether we are going for the normal or the reverse phase chromatography. If your compound reverse phase, that means your compound will be non-polar in nature, you can go ahead with so-called as a reverse phase chromatography. And if your compound is polar in nature, go for the normal phase chromatography. Okay, so you have decided with respect to the phase chromatography. Now prepare a plate or select a plate with the proper sorbent material. Prepare the mobile phase or a mobile phase composition. Mark the plate. Remember, marking the plate is what these steps, apart from the second step, these steps are simply or equally applicable for your paper chromatography also. In paper chromatography also, we will have to prepare the mobile phase. Okay, mark the plate. Marking will be done on the basis of what? The baseline. Okay, apply the sample, that is also called as spotting. Okay, you have already applied the sample with the help of what is used in case of paper chromatography for applying the sample. Write down in the comment box what is used in the paper chromatography for spotting or applying the sample. Develop the plate, that means you have to run out the solvent system inside the saturation chamber, and then after the drying of the plate, go ahead with the detection by using different methods. Okay, what you have used in case of paper chromatography for applying the sample? Write down in the comment box. 2 instruments are there, or 2 apparatus. I'm moving ahead with the stationary phase. Okay, capillary tube can be used. Okay, Praveen, what else? Yeah, Akash, same. Radhika, apart from capillary tube, what else? Okay, everyone is talking about capillary tube. Okay, there is another instrument called as a micropipette, which can also be used for applying the sample or spotting. Okay, so okay, so what is the practical requirement? First we will deal with the what exactly the stationary phase composition with respect to the TLC. Now the adsorbents mix with the water or other solvent to make the slurry. Okay, the adsorbent material which you are going to have get what we can say make a slurry out of it with the help of water or other any micropipette. Injector, no injector as such, we cannot use the injector in case of paper chromatography or even TLC also. Okay, injector is specific for your HPLC. Okay, so this is important part of your GPAT preparation. Okay, these so-called as adsorbent or TLC plate compositions has been so many times you asked in the GPAT preparation itself. Okay, GPAT exam itself. Okay, now there are different grades of silica gel. These grades can be asked so many times: silica gel H, silica gel G, silica gel GF. Then there is another component Kieselguhr G. Okay, now what exactly the silica gel H is? It is a silica gel, activated silica gel without the binder. Remember, it is without the binder. When you can call it a silica gel H. Okay, silica gel H is what? Without the binder. When the H has been replaced by the G, when silica gel H alphabet has been replaced by G, you can call it as a binder. That means silica gel with the inert binder like a calcium sulfate. Okay, silica gel with the binder can be called as a silica gel G. When there is a word G, it shows that the silica gel is with the binder, and when there is a silica gel H as an alphabet, the H denotes that it is without the binder. Okay, with binder, without the binder. Silica gel GF, F has been addition over here. Silica gel binder, which may be a calcium sulfate or any other inert substrate. Okay, and a fluorescent indicator. Remember, GF stands for, G means we know that it is a binder, and F stands for any fluorescent material, so that it can be easily detected by the fluorescence spectroscopic methods or even fluorescence mechanism. Okay, for that purpose you can itself employ your silica gel with the fluorescent indicator, so that it can be easily determined on the fluorescence spectroscopic techniques. Okay, so this is important development with respect to the silica gel, and it needs to be remembered. Okay, so silica gel H means without the binder, silica gel G means with the binder. Binder in most of the cases can be inert solvent or inert substrate like the calcium sulfate, and when the G has been attached with the F stands for fluorescent indicator. Okay, fluorescent indicator. Apart from this, the alumina is synonymous to your called as a silicon oxide or a silica, cellulose powder and Kieselguhr G. The combination of alumina, cellulose powder and Kieselguhr can be used in as a stationary phase also. Now what is Kieselguhr? Kieselguhr is a diatomaceous earth plus the binder. It may be calcium sulfate or any other suitable substrate. Okay, inert suitable substrate. So there are four multiple choice questions over here. When I say silica gel H, it is without the binder, silica without the binder. Silica gel G, it is silica gel with the binder. When I say silica gel GF, it says that it is silica gel with the binder with the fluorescent capacity. And what is Kieselguhr G? It is a diatomaceous earth with its combination to the binder. So remember these for your further references. Okay, so this is how the coater in most of the experimental purposes in academics can be used to spread the silica gel. Okay, this is how the plate looks like. Okay, after spraying on a suitable surfaces, inert surface. It may be a glass plate, it may be a plastic, it may be aluminum foil, or it may be any metal surface which is kept over here, and at the end of it slurry has been poured, and carry out this hand operated coater so that it spreads uniformly. Okay, so this is one of the method for preparation of your plate. Okay, TLC plate. Glass plates. Okay, glass plate is commonly used. What are the different dimensions with respect to the, now these dimensions differ from practical requirements. Remember, these are not so called as a rigid dimensions. You can go ahead with any dimensions if you have, because it depends upon the time with which you have to carry out the analysis. Apart from this, it depends upon the components of the sample. Apart from this, it depends upon the time requirement of the sample. Apart from this, it requires it depends upon the quantity of the mixture which is going to be separated. Hence, these so-called the dimensions may change, but for most of the practical purposes, these may refer to 20 as to 20 centimeter, 20 as to 10 centimeter, 20 as to 5 centimeter. These variations can be possible depending upon the nature of your analysis practical. Microscopic slides, remember this is important for our so-called as the laboratory scale. Microscopic slides can also be used. Plates should be of a good quality, withstand the high temperatures also. Okay, so why you need a high temperature? Because you need to activate the plate. That plate activation is here it is, activation of the plate so that it becomes active, because silica after exposure to the moisture or even atmospheric conditions absorb moisture, and hence it becomes less active. For activation purpose, you need to treat it with a higher temperature so that it becomes, or its sides become active, so that it is helpful in case of separation purposes. Okay, so what I mean to say is the glass plates which we are using may differ in their dimensions from 2020 to 2010 to 25, or even at the simple laboratory scale you can go ahead with the microscopic slides also. Plates should be of good quality, withstand the high temperature. Okay, preparation. There are 4 different methods by which you can go ahead with the preparation of TLC plates. Simply pouring, just prepare the slurry and pour it. Here it is, you have prepared the slurry and pour it on your slide. Okay, pour it on your slide just like this, so that it can spread over all the surface. Okay, this is how the TLC plates prepare. This is called a pouring technique. Then the dipping technique. Yeah, if you have prepared your slurry inside the beaker, just dip the whole plate inside the slurry system or a slurry beaker. This method is called for dipping, used for the small plates, but this is the simplest method. Okay, the pouring is the simplest method. Third is the spraying. If your slurry can be spreadable enough or sprayable enough, it can be poured inside the sprayer and spray it on your plate. It may be a glass plate, metal plate, or your aluminum foil also. So pour it on the spray it. It is difficult right now, because while spraying there are chances that some layers may get more stick to each other rather than other area of the plate, and hence it becomes very difficult to get the uniform layer. Spreading, what we have discussed in this coater itself, spreading is the important and most widely used technique for TLC. For that purpose, TLC spreader can be used. Okay, and what we have to do with the spreader, you just have to keep your plate over here, pour the slurry and carry out the spreading with the help of this coater. Okay, this is how the pouring needs to be done, but you can see that there are certain ways by which this layer cannot be called as a uniform layer. So there are chances that after drying, some layer of or some area of the plate will have higher concentration of slurry as compared to the other area. Okay, and that is not the uniform layer composition with respect to the TLC plates, and hence it is avoided for most of the time. Okay, so for better results you can go ahead with the spreading. Okay, spreading is the good technique. This is the jar. This is the jar, the same jar which we have used in case of paper chromatography. This is the lid for the jar. Okay, that is also called the saturation chamber. Even the simple beaker can also be used for the saturation purposes. Okay, this is the commercial plate. Okay, this is the commercial plate, aluminum foil commercial plate. You can cut it into the desired sizes, which is also present in our college. Okay, we will have a practical on it. You can cut it. You can go ahead with the sampling, the same sampling which you have discussed in case of your paper chromatography can be possible. Just mark them. Okay, this is how the development will be going on. This is where you have to put your plate, okay, inside the beaker or saturation chamber, carry out the development. Okay, the spots will get separated out, distance traveled will be measured, distance traveled by the solvent will be measured, so that you can calculate what they called it as a RF value. Okay, carry out the illumination by using UV chamber, by using iodine chamber, or by using fluorescence detection technique in case of your silica gel GF. Okay, so activation, why you need to activate the plate? Because as we have said, the silica gel has a highest capacity to absorb the moisture as soon as it exposes to the atmosphere, and we need to make the sites available for your separation purposes, and that's why the activation needs to be done. Now how the activation needs to be done? Heating at about 100 degrees Celsius for 30 minutes. You have to keep the plate inside the hot air oven for 100 degrees Celsius for 30 minutes. The plates then get transferred into the desiccator for up to the further analysis. Okay, because the desiccator is a technique where the we can say that with a surety that there should not be any cut of moisture, or moisture is minimal. Okay, so that your plate will remain activated state. Application of sample, we no need to discuss. The capillary tube and a micro pipette, okay, can be used. Okay, just ensure that spotting area should not be immersed with the mobile phase. We all know this. Development tanks, better to develop the glass beakers, jars to avoid more wastage of the solvent. You need not to go for bigger jars and bigger beakers. You can develop the TLC plates with the simple small beakers also, so that there should not be any wastage of the solvent. Standard method is use the twin rough tanks. You can use for the twin trough tank, sorry, so that you can have the different compositions of the sample. If there are compositions of the sample, two compositions in one tank, you will go with the first composition, remove the plate and go ahead with the second tank, that is twin trough tanks. Also do chamber saturation to avoid the age effect. As why you need to saturate the chamber? Because there should be the uniform distribution of the solvent system, and if the solvent will not be get uniformly saturated in your so-called as a beaker or some saturation chamber, there may be possibility that at a particular end of the plate or at a particular end of the paper, there should be excessive concentration of the solvent as compared to the other surfaces. Okay, to avoid this so-called age effect, you need to saturate the temperature jar. Okay, mobile phase, we all know mobile phase depends upon the nature of the substance, its polarity, its affinity towards the stationary phase, nature of the stationary phase, mode of chromatography, whether you are going for the normal phase chromatography or reverse phase chromatography. Separation to be achieved, it may be analytical and preparative. Remember, analytical will require its own composition of mobile phase, and preparative chromatography will require its own phase of mobile phase. Most widely used mobile phase or a combination of it requires pyridine, petroleum ether, carbon tetrachloride, acetone, majorly used water, glycerol, ethanol and benzene are the widely used mobile phase or even in the composition. Okay, development techniques, we already dealt with it. Okay, 1, 2, horizontal development, multiple developments, like you can go ahead with a number of what we can say 90-degree dimensions. Okay, 90-degree dimensions for multiple development. development. Okay, detecting or visualizing the agents: iodine chamber, sulfuric acid spray reagent, UV chamber fluorescence, and fluorescence stationary phase are some of the ways by which non-specific detection can be possible. Spray reagents, we already dealt with the spray reagents, which we have already dealt it in the paper chromatography, like detection of glycoside, like detection of alkaloids, like detection of amino acids, ninhydrin reagent. Then there is a sulfuric acid also. What else? Just write in the comment box. Okay, what we have discussed in case of spraying reagents. Quantitative analysis, Rx value, RF value, we already dealt in the last lecture, so no need to discuss. Quantitative analysis, direct and indirect method, that is Rx and RF values. What are the application? You can go ahead simply with the purity of sample, examination, identification, biochemical analysis in pharmaceutical industries, separation in multi-component pharmaceutical industries, and in food and cosmetic industry. You can elaborate it, you can get the idea in the books itself. So this is the small session on the TLC, because as per the session itself, syllabus itself, it should not be going ahead of the 1 hour lecture, and it is what we can compare it with the paper chromatography, so you can easily compare and understand the TLC with respect to the paper chromatography. Yes, drag and drop reagent is there. Okay, drag and drop reagent is there. Okay, so I think this summarizes our chapter on the TLC. If you have any doubt with respect to the TLC, you can raise it over here. We are running short of the time. Ninhydrin and acetone solution, we already said it. Okay, we are running out of the time. We will meet in the next session with a different topic. Till then, take care. Okay.